Hello, Algebra 2 classes. Long time no see, and it's going to be longer. I'm going to be gone all this week again, still here at the hospital. I'm actually sitting in like a waiting room right now. You can see it's, oops, I don't know why the screen changed. It's all colorful for the children's hospital, and I'm sitting here talking to myself into an iPad. It's about midnight, and there'll probably be people walking by looking at me like a freak, talking to myself, doing math here in the corner. But so if I stop, that's probably why. So I was giving you guys some worksheets last week. Look a lot like this. I put some equations on there that you may not have known how to solve, and so I wanted to talk about those a little bit. I'll have you turn in all your homework for the last 2 weeks on this Friday. So after today, you'll have 4 worksheets. You should already have 3. And then you'll probably get another one tomorrow and Wednesday. Or no. Let's see. My days are off. You'll get a few more this week. So you should have 6 by the end of this week. I'll probably give you Friday just to work on anything you need to and finish it up and staple it all together and turn it all in. And I'll hopefully be back next Monday. So I'm going to start with a little game here. I'm going to read, you're going to try to guess my number. It's called the Guess My Number game. It's pretty exciting. I'm going to read a little description about my number, and you're going to try to guess what it is. Just go ahead and holler out your answer, and the first person to get it right will win a nice prize, hopefully. Mrs. Richards will pause the video if you need time to think about it, because I'm going to go kind of quick through these. So just pause once I read it. So the first one, guess my number, says if I take my number, multiply it by 3, and then add 4, I get 19. So what is my number? Go ahead and pause it. Okay. Hopefully you guessed right. You should have gotten 5. Because if I take 5 and I multiply that by 3, I get 15, and then add 4, and you get 19. Okay, the second one. If I take my number, subtract 7, then divide by 2, I get 10. Pause it now. Alright. So you should have gotten 27 as your answer. Because 27 minus 7 is 20. Take that, divide by 2, you get 10. Hopefully some of you have caught on to a quick way of doing this. Like up here. Hopefully you figured out, if you're talking to each other, like, how'd you get that so fast, whatever. This is a lot easier to play when I'm there. We'll do it again. We'll make it harder once I get back, but if you just work backwards, like here, if you start with 19, work backwards and do the opposite thing. So instead of adding 4, subtract 4. So if I go 19 minus 4, I get 15, and then divide by 3, I get 5. And that's just a quick way of getting the answer, working backwards and doing the opposite thing. Wish I was there to see it. Usually people catch on to that kind of fast. So I think you've seen stuff like this before. Here, same thing. Just work backwards and do the opposite. So take 10, multiply by 2, you get 20. Add 7, you get 27. So my number would have been 27. Okay, so now that you know that, try to do this last one. It's a little harder, but try to work backwards and do the opposite thing. See if you can get the number. Again, first person to get it, well, you're probably getting like lifesavers or dum-dums. Here you go, here's the last one. If I take my number, square it, add 3, then divide by 4, I get 3. Go ahead and pause it. And your answer should have been 3. Let me draw my clipboard. So what does this have to do with anything? Why are we playing this? Well, when you're doing this, when you're working backwards and doing the opposite thing, you're actually just solving an equation without realizing it. If you notice the video is choppy, it's because I'm pausing the recording every once in a while. Like, there was just a woman pushing a cart by with a bunch of food on it, and it was noisy, so that's why it's choppy once in a while. Anyway, so I said you're solving an equation without realizing it. Like this first one, this is actually an equation that we could solve. Like, if I take my number, we'll call my number x, that's what we usually use, it's a variable, could be anything. Multiply it by 3. Well, in equations, if we write numbers next to each other, 3x, that means multiply. Then add 4. Add 4. I get, so I'll equal 19. Now if I solve that equation, most of you should know how to solve that, it's basic. It's just the same as working backwards through this and doing the opposite thing. So here most of you would know, oh, I should subtract 4 first from both sides. Well, if I work backwards through this, I'm going to go and I'm going to subtract 4 from that 19, which is exactly what's happening over here. So 3x will equal 15. Working backwards, divide by 3 here. Oh, hey, I've got 3 times x. Always doing the opposite. Divide by 3. And that will equal 5, which was my answer. So when we're doing the opposite, these are called inverse operations. Inverse meaning just doing the opposite of whatever's there when I'm solving an equation. One way you could think about it, oh no, I'll show you that later. I'll do it right now. I'm just out of room on my paper. If I'm solving that same equation, 3x plus 4, you learn that the order of operations when you're simplifying stuff last week was PEMDAS, of course. You work with that a little bit. It's parentheses, exponents, multiplication, and division. Here comes the noisy cart again. Addition and subtraction. You learn you work through that way if you're trying to evaluate something. Well, if you're trying to solve an equation, you work through if you work through this backwards, you'll solve the equation for x. It's late, so I'm having trouble finding words here. So like here, if I start here and I go backwards, so I'm going to start with addition and subtraction. Well, where do I have addition and subtraction? Right here. So I want to get rid of that first. Do the opposite. Do the inverse operation. Subtract 4. We just solved it, so you know how to do it. And then here now I have multiplication, so I'll do the multiplication and division, and that one's pretty easy. But working backwards through that will work on any of them. Down here, same thing. Take my number, subtract 7, divide by 2, I get 10. That would be the equation for that one. Well, working backwards. Some of you, I think you had one of these on your worksheet the other day for homework. If you got stuck, I don't know how that went, but if you got stuck on that, because of this 2 down here, working through this backwards, you might be like, oh, addition and subtraction first. I have that right here. I'll add 7 to both sides, which is a common mistake. Because remember, if I'm going to add 7 to this, I have to add it to the whole side of the equation, and it would be weird. I would have like x minus 7 divided by 2 plus 7. This 7 is actually getting divided by 2 because it's this whole top piece divided by 2. So you can't just add 7 to that. It's not going to get rid of it. So here, you want to get rid of that 2 first. If you multiply the whole side by 2, and whatever I do to one side, I have to do the other. So this is all divided by 2. I'm going to do the opposite, multiply by 2. Well, I could write it out. I'd have 2 times x minus 7 divided by 2. Well, if I have 2 divided by 2, that's 1. Or you could show it another way of thinking about the same thing. If you had 2 times x minus 7 on top, well, that's the same as, distributive property. That'd be 2x minus 14 over 2. And if you simplify that, you have to divide them both by 2. 2x divided by 2 is x. Negative 14 divided by 2 is negative 7. So no matter how you think about it, probably just confused a lot of people. You have x minus 7 equals 20. Long story short, you just multiply both sides by 2. And then, of course, add the 7. bam, you get 27. Same thing down here, this last one. Working backwards, hopefully most of you just did it in your head. You could multiply by 4, subtract 3, square root it, that's the opposite of squaring, or the inverse operation. And then you'll have the number, or if I write it as an equation, take my number, square it, add 3, divide the whole thing by 4, and I get 3. So to solve that, I want to get rid of that 4. I don't like those ugly fractions like that, so I'll multiply by 4 on both sides. Got x squared plus 3 equals 12, subtract 3. So x squared equals 9. In here, inverse operation of squaring is the square root, right? Squared and square roots are opposites of each other. We can talk more about that later if you want. But so I square root both sides. So I get x equals, and normally right now I'd ask you what's the square root of 9, and most of you would say 3, and I would say yeah, that is correct, or it used to be, but now it's not fully correct, because now we know the square root of 9 could be positive or negative 3. There are two answers. Because right here at the bottom, I have x squared plus, x squared equals 9. Well, this is like saying, what number can I put for x to make this true? Well, positive 3 squared gives you 9. That's true. But also negative 3 squared gives you positive 9. Negative 3 times negative 3 is positive 9. So whenever you square root something, whenever you have x squared equals a number and you square root it to get the answer, you're going to have two possible answers. And that'll come up later. Okay, and now I just have a few example problems that I want to show you just real fast. It'll be similar to stuff on your homework sheet today, just solving equations. You've already had one like this before. Sorry for the shaky camera. But there's multiple different ways you can do these. I'm going to just drop something. Multiple different ways you can do these. Order you can do things in, and it doesn't matter as long as you're making legal mathematical moves. And when I get back, I'll help you with some of those, and we'll figure all that out. But like here, I can see I got x's on both sides. So whenever you see that, you're going to want to get all the x's to one side and all the other numbers to the other side to be able to solve the equation. I said PEMDAS backwards. Hopefully you know not to add those by now, because you don't want to do 2 plus 3, because this would be multiplication. You could distribute that 3. That'd be fine. Yeah, we could do it that way. Or we could, I don't like this 2 sitting down here. Let's subtract the 2. You subtract 2 from both sides, we're good. Now I got 3 times x minus 4 equals, only subtract it from this, right? Like terms only. Don't subtract 2 from an x. It's got 8 minus x. Now we're here. You could divide by 3, but that's going to get ugly over here. So I would just do a little distributive property, right? Multiply this out. 3x minus 12 equals 8 minus x. Get all the x's on the one side, all the other numbers on the other side, and we'll be done here. So add x. Got 4x minus 12 equals 8. Add 12. 4x equals 20 divided by 4. Oops. Again, I don't know where you're coming into this. I don't know how much you remember from Algebra 1, if that's simple or if that's challenging. So I'm just going kind of fast here. Like I said over here, there's 2 ways to solve this. I'm going to pause because there's a loud garbage can coming. There's 2 ways to solve something simple like this. I've just got the same equation written twice. One way, you can always do distributive property. You can go 2x plus 2 equals 10, and then subtract 2. 2x equals 8 divided by 2. X equals 4. You can always do it that way. But I think you'll find as you go on, sometimes it's easier. Instead of distributing that 2, well, this is multiplication. You have 2 times this whole thing. Well, do the inverse operations. Do the opposite. Opposite of multiplication is division. Divide the whole side by 2. Boom. x plus 1 equals 10 divided by 2 is 5. Subtract 1, you add x equals 4. It was one less step there. On other problems, it may cut out more steps. It just depends. And I know I'm writing fast and going through these very fast. You don't necessarily need to be writing these all down. This video is on YouTube. You can go to my channel and subscribe, and you can see all these videos that are there. I think I'm up to like 9 subscribers now, so I think I'm going to start getting paid pretty soon. One of my videos has like tens of views and like some likes, so that'll be good once I start getting paid for that. So anyway, yeah, go there, check it out. Show you a few more equations here real fast. Something like this with a square root in it. That's like parentheses. Weird part about square root is you can't just do distributive property. There's like the little trick is there's like a ceiling there. You can't distribute because it's like, oh, it hits the roof. Like it can't go in there. No, you can't do that. But it is 2 times the square root of x plus 3 minus 4 equals 2. So let's go through and get rid of stuff. If we're working through PEMDAS backwards, we'll get rid of addition and subtraction first. These guys are in jail. I can't touch that yet. But I can add 4 to both sides. So I'd have 2 times the square root of x plus 3 equals 6. Now I said this is multiplication, so to get rid of that 2, we'll divide both sides by 2. Square root of x plus 3 is 3. Now we got to get rid of that square root. We got to get those guys out of jail before we can do anything. We can't subtract 3 here. They're stuck in there. So to get rid of a square root, we do the inverse. We do the opposite. Opposite of square root is squaring. So I square both sides. Square root of x plus 3 squared. Well, square root and squared are opposites of each other. That leaves us with x plus 3. 3 squared is 9. Boom, now it's easy. Subtract 3. X equals 6. Just nurses walking by talking about cutting someone's nails. Here, same thing. Just now it's a third root. I don't know how much you know about third roots or third power. For example, 2 to the third power, you should know that means 2 times 2 times 2. So the opposite of that would be third root. So if 2 times 2 times 2, that's 8. Well, the third root of 8, that just means what number times itself 3 times gives you 8? Well, the answer is 2, because 2 times 2 times 2 is 8. So third root, third power are opposites. Square root, squaring are opposites. If you add a fourth power, you could do fourth root. Fifth power, you can do fifth root. Those are all opposites of each other. And you write the little number like that in there. So like to solve this, we'll get that little piece by itself. So I can subtract 3. I got a positive 3 out here. I'll subtract 3 both sides. Don't forget this negative. This is negative the third root of x plus 2 equals 1 minus 3 is negative 2. That doesn't mean negative 3. It means negative times the third root of that. So you can think of it as like negative 1 times all that stuff. So to get rid of that negative 1, divide both sides by negative 1. Bam. Third root of x plus 2 equals 2. Now, like I said, do the opposite of third root, third power. So take both sides of the third power. You got x plus 2 equals 2 to the third. That's 2 times 2 times 2. That's 8. Subtract 2. X equals 6 again. I don't know how that happened. So there you go. Working with roots to get rid of get it down to where you get the root by itself. And then do the opposite. If it's third root, do third power. Square root, square it. I think that's all I put on your homework. Stuff like this where it is squared. Get that piece by itself and then do the opposite. So like here I have 2 times all of this. I can't distribute. I can't do my multiplication before exponents if I were going to simplify it. So I'll work backwards. I'll do inverse stuff. I'll divide by 2 on both sides. X plus 1 squared equals 32 divided by 2 is 16. Opposite of squaring now. I'll square root both sides. So I have x plus 1. This is where it gets tricky. Who remembers what the square root of 16 is? remember, so I guess we haven't talked about the square root of 16, but we talked about square roots. Hopefully someone said you have to use plus or minus 4. Because, well, we could explain that more later, but you're going to have 2 answers for this. This lady's talking very loud, so I'll hold on for a second. You're talking about fish. There's fish on the walls. Anyway, this is going to be the weirdest video ever. But, you got here, we'll subtract 1. I have plus or minus 4 here. So there's basically 2 answers. So I have to do it twice. I got positive 4. This is like 2 different problems right here. I have positive 4 minus 1, which is 3. And I have to do negative 4 minus 1, which is negative 5. So yeah, there's that. I also gave you some like this. Kind of already talked about it. You've got division there, so get rid of that first. That's ugly. Nobody likes that. As soon as you look at that, you're like, oh crap, that's weird. I don't know what to do. Well, just think about it. You got a big old division right there. So multiply both sides by 2. Gets rid of those. You'd have 3x plus 1 equals. Well, when you multiply this side by 2, you got to multiply the whole side. Distributive property, I'd have 2x plus 4. Once you're there, get all the x's to one side and the other numbers to the other side, and you're done. Same thing here. You have fractions. You're going, oh no, fractions. Well, it's not that big a deal. How do I get rid of, I mean, the thing that's throwing me off is this x plus 1 on bottom. If that wasn't there, this wouldn't be bad. Well, 3 equals 4 is not true, but so to get rid of stuff on bottom, we just multiply. We do the opposite. So if I multiply both sides by x plus 1, so times x plus 1 times x plus 1, well, what happens over here? Those go away. It's going to be 1. I'll have x plus 1 over x plus 1. Over here, it may look a little complicated, but it's just multiplying by x plus 1, so it's like that. You just got to multiply the top. It's like multiplying the bottom by 1. So over here I'll have a 3, and then here I have to do distributive property. I'll have 4x plus 4 all over 2x. And most of you will do this, what I'm about to do in 2 steps, you'll do in 1 step. Because you'll also know, hey, I got to multiply both sides by 2x now. That's gone. So now 2x times 3 is 6x equals 4x plus 4. What I just did there is basically cross-multiplied, but I don't like to say that. That's like a cuss word. So, because people always think that cross-multiplying is like the solution for everything, when if you don't know what you're doing, you'll get yourself in trouble, and you'll be in situations where you'll try to cross-multiply, and it's just ridiculous and not the right thing to do. So, I got a fraction by itself, I multiply both sides by whatever's on bottom. Hey, I got another fraction by itself, I'll multiply by whatever's on bottom. Get here, get your x's on one side, and done. So now that I've thoroughly confused most of you, you'll have a homework sheet. 9 problems, 9 equations. You'll have fraction looking ones. There's 3 of those on bottom. Got some roots in there. Like that one you'll eventually have to square. That one you'll have to do the third. So try those out. And then tomorrow we'll learn how to do a new kind of equation. We'll do absolute value equations. And maybe that's just it. Absolute value equations. And you'll have another worksheet. So have fun.